Imagine a star so massive that if placed at the center of our solar system, it would swallow Mercury, Venus, Earth, Mars, even extend beyond Jupiter. This isn't science fiction, it's Betelgeuse, the enormous red supergiant in the constellation Orion. For centuries, people have looked up at it with awe, not knowing they were witnessing one of the most powerful stars in our galactic neighborhood. Betelgeuse isn't just a point of light in the sky, it's a ticking cosmic time bomb, and in our lifetimes, we might just see it explode. It sits roughly 642 light-years away from Earth, close enough that if it does go supernova, the event will be visible in the daytime sky. You could walk outside, look up, and see a star shining so brightly it rivals the moon. It would last for weeks, maybe even months, lighting up the night and casting shadows. Ancient cultures used Betelgeuse in navigating their stories across the stars. Some saw it as the shoulder of the great hunter Orion, others as a celestial heart pulsing in firelight. But what makes this star truly remarkable isn't just cultural myth, it's the science behind it and what it's trying to tell us right now. Right now, Betelgeuse is dying, but it's not going quietly. Over the past few years, astronomers around the world have watched as its brightness dipped dramatically, so much so that many thought it was finally going supernova. In late 2019 and early 2020, its light faded like the quiet before a cosmic storm. For a while, it became noticeably dim to the naked eye, sending astronomers and the public into a frenzy of speculation. Was this it? Were we about to witness one of the rarest events in human history? Telescopes across the globe locked onto Orion, trying to catch a glimpse of what might come next. Even the most advanced observatories in orbit, Hubble, and more recently, the James Webb Space Telescope, were redirected to observe the event. The dimming didn't just intrigue astronomers, it terrified them. A supernova this close would be a scientific miracle, but also deeply unpredictable. Yet, after months of faintness, something unexpected happened. Betelgeuse returned to its former brightness, almost as if nothing had happened at all. This wasn't the end, it was a clue. Every massive star goes through stages. First, it fuses hydrogen into helium, like our own sun. Then, as it ages, it starts fusing heavier elements, carbon, oxygen, and eventually iron. The moment it reaches iron is a death sentence. Iron fusion sucks energy rather than releasing it, and at that point, gravity wins. The core collapses, and in less than a second, the entire star detonates in a violent display of energy, a Type 2 supernova that can outshine entire galaxies. The outer layers are blown into space at thousands of kilometers per second, while the core is crushed into either a neutron star or a black hole. But Betelgeuse's story seems more complicated. When James Webb turned its golden eyes toward this red giant, what it found was not peaceful or quiet, it was chaos. The surface of Betelgeuse was alive with turbulence. Gigantic convective cells, regions where hot plasma rises, cools, and sinks again, many times larger than our Sun, were rippling across its surface. Enormous bright patches and star spots dotted its body. Most striking, Webb detected colossal ejections of gas and dust, far larger than anything seen around a star at this life stage. Where most stars casually release mass via gentle stellar winds, Betelgeuse was violently hurling part of itself into space. These ejected clouds of dust eventually cooled and condensed, forming veils so thick they temporarily blocked the star's visible light. This was likely the cause of the dramatic 2019 dimming, not a sign that the star was dying, but that it was coughing. Imagine a balloon struggling to hold in all its air and suddenly releasing a burst of it through a massive tear. That's what Betelgeuse seemed to be doing. These mass ejections, once only theoretical, were finally observed in real time, and it was as if the star was writing a message across the cosmos in glowing dust and gas. I'm not dying yet, but I'm changing. For astronomers, this information was groundbreaking. For decades, the late stages of massive stars were modeled with relatively smooth transitions, an orderly procession from fusing one element to the next before an inevitable collapse. But Betelgeuse has shown us that reality is far more volatile. These episodic ejections, brightening and dimming phases, and dynamic surface activity suggest there's much more happening in the final decades, or centuries, before a star's death than we ever imagined. Now, scientific institutions worldwide are on alert. Facilities designed to capture some of the universe's rarest signals, namely neutrinos, are standing by. These nearly massless particles are born in the instant of core collapse and escape from the dying star before any light. Neutrino detectors deep beneath Earth's surface, like Japan's Super Kamiokande and the Ice Cube Observatory buried beneath Antarctic ice, are acting like early warning systems. They'll hear the stars scream before we see the explosion. And then there's the fabric of space itself. As Betelgeuse collapses, it may send ripples across the universe, gravitational waves. These shifts in space-time, first predicted by Einstein and only recently detected by observatories like LIGO and Virgo, offer yet another piece of the puzzle. Astronomers are now synchronizing neutrino data with gravitational wave observations and electromagnetic signals, from radio waves to gamma rays, all to build a multi-messenger picture of what happens when a star dies. This kind of coordination has never happened before, and Betelgeuse is offering a once-in-a-lifetime scenario. Because it's relatively nearby, the light from its supernova won't be dimmed by cosmic dust like explosions we've seen in distant galaxies. Every frame, every moment of the explosion could be captured in extraordinary detail. We won't just see it, we'll study it, dissect it, understand it. We're talking high-speed spectrographs capturing the explosion's chemical signatures in motions, infrared sensors watching dust clouds unfold, X-ray telescopes monitoring the shock wave as it punches into surrounding gas. We'll track the blast's echoes moving through space, bouncing off material Betelgeuse had shed in its years of instability. And all of it will happen quickly. Within hours of the neutrino burst, our entire global network of observatories will spin into motion like gears in a well-oiled machine. And here's the thing. We don't know when it'll happen. It could be tonight. It could be in 50 years. Stars, even dying ones, don't keep appointments. But what Betelgeuse has already given us is remarkable: insight, mystery, and the drive to be ready at a moment's notice. Even though the eventual supernova will be completely safe here on Earth, our distance protects us from harmful radiation. It might still stir atmospheric effects. There's speculation that auroras could temporarily appear at lower latitudes, lighting up skies in parts of the world not used to such natural wonders. We might get light shows not just in the night sky, but potentially visible flickers during daylight, a cosmic whisper of Betelgeuse's final breath. And while the observable science is crucial, there's also a human side to this event. For millennia, we've connected the stars to our stories. From the ancient pyramids aligned with Orion to cave paintings and nautical traditions, the red glow of Betelgeuse has been a constant. The night it shines like a second moon, people will gather around the world, on rooftops, beaches, mountains, smartphone screens tilted upward, feeling something ancient stir inside them. People who've never studied physics will be asking about stellar life cycles. Kids will point to the sky and ask, "Is that the one?" Conversations sparked by a dying star will ripple through homes, classrooms, and online communities. Betelgeuse won't just be an astronomical object, it'll be a moment in human history. Like the eclipse that turns daytime to night, or the comet that appears once in a generation, It will become a collective memory, shared across borders and beliefs. And once the immediate light fades, the remnants will keep on glowing. Maybe a neutron star will remain, a city-sized object so dense that a teaspoon of its matter would outweigh Mount Everest. Or maybe it will be a black hole where not even light can escape. Instruments will continue scanning the remnant, analyzing the aftermath of one of nature's grandest events for decades to come. The star may be gone to our eyes, but its ashes, both literal and metaphorical, will seed new research, new discoveries, even new stars. Betelgeuse will enrich the region around it with heavier elements, scattering iron, carbon, silicon, maybe even uranium throughout the Orion molecular clouds. Those clouds, over millions of years, will birth new stars, new planets. Some of those planets may one day harbor life. So in watching Betelgeuse die, maybe we're also witnessing the beginning of something else, the origin of worlds not yet born, and that, truly, is the cosmic cycle playing out before us. Stars give life and then surrender themselves so that new life can begin. Our bodies, the earth, the oceans, everything we are, comes from stars that exploded billions of years ago. Gold on your ring, calcium in your teeth, iron in your blood. It's all star stuff. So in a poetic sense, when Betelgeuse dies, a part of us dies too, and something new is born. It's easy to think of the stars as cold and distant, forever out of reach. But Betelgeuse reminds us how intimately connected we are to the cosmos. And it teaches us something even more powerful: patience, preparation, and curiosity.